In this video, we will talk about parameter expansion in Bash. Parameter expansion is actually the concept that groups the set of operators that Bash offers to write one-liner expressions around parameters or variables in general. And those expressions are much more efficient in the sense that to achieve an equivalent result without using parameter expansions, it would be needed to write more codes or to use some external tools. So these parameter expansions offer the possibility to write more compact and efficient code. Let's start with the colon dash operator. With the colon dash operator, the parameter is evaluated, and when it's unset or null, then the expansion of the value is used instead of the parameter. So let's consider a case where we declare a variable name and set its value to Bob, for instance, and want to print name out. So we are in the context of the equal dash operator, and we want to print the name. So in this case, Bob will be printed because the value is set. The value is set to Bob. But if the value is not defined, then nothing will be printed as the value. And that's where we can use the colon dash operator to define a default value for our variable, for instance. So if name is not defined, then use the value Tom as the default. So as we have commented out, the line declaring the variable name therefore does not exist in the scope, then Tom will be printed as a default. And the value that is used as default is also expanded, which means that its value can also be another variable. So let's declare a read-only default name and set this to Tom. And instead of using Tom as a literal here, we can just use the variable instead. And this will also executes all fine, because whatever is defined after the colon dash operator is also evaluated. And if we will actually implement this literally, then it will be written like if name defined to a 0 length string with the -c option, then we want to echo name 0 length, it means it's not set or is empty, then we want to use the default name. And if not, we put name in lowercase. Name or print now our variable name. And so this if condition written here is equivalent to this single line using the parameter expansion. So running both will yield the same result. And if we define Tom as Bob, then Bob will be used because then the default value is no longer needed, since the variable itself is already set to a defined value. The next one is the colon equal operator, and the colon equal operator is a little bit similar like the colon dash operator. And the difference is that when the parameter is evaluated, if the parameter is unset or null, then the value is assigned to the parameter instead. So if we use dash instead of, we use equal instead of dash, then if we echo the name, we can see the difference this way. I'll print it for the dash colon dash also, and then we could see more clearly what the difference between the two. Here I have name is defined to Bob, so we want to comment this out to have name undefined, and then we can see this line prints the default value as we use the colon dash operator as expected, but the name itself, the name variable, is unchanged. So name here prints nothing. Yeah, as the name variable itself is not changed. However, with the column equal operator, we see a similar message, but the default value is assigned now to the variable name. So when we print the variable name on its own, it has the value Tom now. That is the content of the default name. So that's the slight difference. So this would be equivalent to having if name resolves to a 0 length string, then name equal default name. So we're setting name to default name, and then end, and then echo name and name. So this single line is performing actually this operation. When the variable is not set, then it assigned the value specified to the variable and then move forward. The next operator is the colon question mark operator. And the colon question mark operator evaluates the parameter. And if the parameter is not set, then it prints the message or the value specified after it on the standard error output. And this is practical to check if some parameter that is required in a script, for instance, is set. So if we need our name value, we can do it this way, and then define an error message that should be printed. Name is not defined, is required but not defined. So this way. So it means that name somehow is required in our script and we want the user to define it. So with the column question mark operator, the variable name, when evaluated and not defined, then the error message will be printed. In this case, then it says name is required but not defined, with the line where the error occurs, which is a little bit more handy. Prints the script and the line number. But if we declare our variable name, then the script will execute without any error. Yeah, and that's the usefulness of this. And if we will actually write this ourselves without even debugging information, it would be like if name evaluates to an empty string, then echo name is required but not defined, and exit 1. Because when this error is encountered, then it's print the message and also returned a non-zero exit status. So here name is defined, then it will execute without error. And if I comment out this and to run, I can run this first, and then we see that once the message is printed, nothing else is executed because there is also the script exit, and we can check the exit status with the question mark special variable, and we see that the exit status is 1. So it is equivalent to our script manually written here this way without the debugging line number. And we have name is required but not defined. And if we check our exit status as well, then we have an exit status of 1. And the next operator is the colon plus operator. And the colon plus operator evaluates the parameter. And if the parameter is set, or if the parameter has a value, then the expansion of the value specified after the colon plus operator is used. Let's say name, and we want the variable name colon plus, let's say Tom. So if I run the script, we just have name and nothing else because the variable name is not defined. But if we declare the variable name and set it to John, then it will print Tom. So basically, if the variable is defined, then use the value that is provided after the colon plus operator. So this is what this line means, and it's practical when you want to check if some condition exists to use a value. So instead of name here, this could have been a flag. And let's say if is user equal 1. So if this flag is defined, it means that the user is enabled. Then we can do it this way. If user, then use print the name of the user. We could have something like this. And then mean, okay, John. But if the variable is not defined at all, it means that its user flag is not enabled. Then print nothing or something like that. And the literal implementation of this would be if name or is user is a non-zero length string, then echo name. So if the variable is user has a non-zero length, then print the user. And these two are equivalent. Yeah, and this is just more efficient to write on having the whole if extraction. There is the substring operator, and the substring operator allows to get a slice or a substring from a string variable. So if we declare greeting, a variable greeting to be hello world, for instance, and we want to get the name world, then we can use the offset, the column offset. So you want to use dollar braces, the name of the variable, followed by a column, and then the index, the offset corresponding to where the world starts from. So it's 0 in strings are 0 index. So it means 0, 1, 2, 3, 4, 5, 6. So from 6 we will get world till the end. So if we provide offset sys, I'll call this sub str1 or substring 1. Oh, I do not mean declare, but echo. So substring 1 just turns world because the world starts from index 6 till the end. But if we want to get a specific length after indicating the starting index, we just need to specify, we just need to use another column and specify the length. So if we want to get only the hello part, hello start with index 0, of course, and hello is 1, 2, 3, 4, 5 length. So the length is 5. We want to start with index 0 and get a length 5, and then this will provide us with only hello. You can actually add single quotes and make sure that it does not include the space between the two words. So it's just hello, and this is also just world. And with the substring operator, we can then just cut any part of a string. So if we want from the third index a string of length 5, or let's say 6, then we get blue word. So column, starting index, and column length afterwards if needed. If not specified, then it goes till the end of the string. The exclamatory operator is actually very handy when there are a lot of variables. When variables have a predefined prefix, so let's say we declared a set of variables, and all of them are starting with x, for example, name, Tom, age, and sure, let's make it an integer, it's all good, 60, and declare as underscore home, let's call it hometown, and this will be Bashville, and so on and so forth. So with the exclamatory operator, we can get the list of all the variables starting with a specific prefix. So if we want to get all the variables starting with the x underscore, then we can do s underscore star. This will perform like a regular globbing match and match with all the variables that start with the exp underscore character, and this will print the list of all these variables. So if we run this, we get exp age, exp hometown, and exp name. So this is what this operator is for. Then if all your variables have such a prefix, then you can use it to get a list or a variable dump of all the variable defined in the context of the script. For instance, to check if they have the values they're supposed to have, and so on. With the star, all the variables are returned as a single word. So basically, if I use for, let's say, variable in this, do done echo variable, we will see that all the variables are printed as a single word. I can comment this one out. So all the variables are printed out as a single word, but if I want to loop through the variables list, one after the other, instead of star, if you use add. And add will perform a word split on the list of the variable, so that I'll be able to loop through them one after the other. So if I run again, then I could print age on its own line, hometown on its own line, and name on its own line. And if I combine this with the reference, I can even print the values basically. So if let's say I declare a reference ref to variable, then I can do variable equal and ref, because ref would print the value referred by the variable, and then I can show the full list. And here, by looping through with the reference, I can print the value associated to each of the variables. Yeah, so this is the advantage of the add, or the feature of the add instead of the star. So if you just need the list of the names and want to do nothing with it, then just listing all of them with the star would be already fine. But if you want to loop through it to, yeah, like in this case, use for instance a reference to access the values, then add is pretty handy, because then bash performs word splitting. Let's say I declare an associative array with the dash capital A, and I call the array info, for instance, and it has name that is equal to Tom, and username that is Tommy, or let's say just like this. The dollar braces exclamatory construct allows to get all the keys of an associative array. Yeah, so if I want to get the full list of the keys of an associative array, then I could do dollar brace exclamatory and info, and use the brace, the brackets and star to say, okay, I want the keys of the associative array info, and star means all the keys, and this would print our name and username, as those are the two keys that we have in that array. So the exclamatory operator can also be used, yeah, on associative array to get the full list of the keys that are available. The pound operator returns the length when it's applied on a string. So let's say the AXP hometown, or example hometown variable, if we want to get the length of that variable, then we could just do, I'll put it this way, length of this equal, then between the braces pounds, and then the name of the variable. And this will return the length of this variable, which should be 9 characters. Oh, let's run this, and this returns 9. But if the variable is an array, an indexed array, so we can declare any example of index array with the -a option. The languages array, C, C++, Python, bash Java, let's say this way. Then we can also use the pound operator to return the length of the array. So length of the array length would be equal to. So in this case, we need to specify brackets and star or at. These two are equivalent and will return the number of elements or the length of the array. So yeah, this return 5, which is 1, 2, 3, 4, 5 elements in this array. We can also use the pound operator, but after the variable name in this case, to perform to return the shortest or the longest match of a string. The longest match are based on a regular expression. So basically, we specify the variable that we on which we want to apply the match, and pound means that we want to look for the match from the beginning of the variable, and if it's a single pound, it means the shortest match, and if it's a double pound, it means the longest match. So let's say we have our variable hello world and happy coding. Let's say we have this as the string on which we want to apply a match, and we want everything from hello world, so everything after hello. So we need to look for a match at the beginning of the string. So to get the match at the beginning of the string, our variable here is greeting, and with greeting we add the pound character after the variable, unlike with the length where the pound is before the variable name. We add pound after the variable name, and we want to match, let's say, hello with a blank. Yeah, so here we just add hello and a blank. I forgot the closing quotes again. And this returns world and happy coding because it returns everything from the string after deleting the match or the pattern that we have specified. So the pattern that has been specified here is hello white space, so it will match the beginning of the string and remove it and return everything that is left over, which is a world and happy coding with exclamatory at the end. But we can do this also using globbing or regular expression. So we want to match anything until a white space. So star means anything until a white space, and the single pound means the shortest match till a white space. And this will also give the same result as before world and happy coding. Star means we want to match anything until a white space, and pound the shortest match. But if we change this for the longest match, it means that the longest match would be this part. It means any character until a white space would be the longest match, and in the end we will just have coding exclamatory printed. And this is coding exclamatory, and this is very handy when, for instance, trimming some parts of a variable. then it's very handy to do it this way. Yeah, let's say we have a variable or a path. Also, there are other ways to achieve this. Let's say we have a variable path that contains, let's say, a custom path to a file, and we just want the file part of this whole expression. We can use this kind of expansion to delete the whole beginning and just keep the file. It's possible to use a base name command, but for the purpose of the example here, we can just achieve the same doing this. Now we have our variable name followed by double pound because we want to delete the longest match, and anything until a slash will mark everything until this part, and then we will just have file printed out when executed. Now, very practical for trimming. And to do the opposite way, so pound match from the beginning and to match from the end, we can use the percent line. So let's say we want this time to match the first, everything from the end until a white space or a single space. We can use, instead of pound, we use percent, and we want to match a single space followed by anything, but from the end of the string. This is what the percent is for. And this will remove that match and return the rest of the string. So it will remove space coding exclamatory and just return hello world and happy. But if we use a double percent and say any white space followed by any character, then it will match this whole part, and we'll cut it off and we'll just return hello for this match. So that we see it easily, I will just do %%, and here I will do pounds and pounds. Yeah. So execute, and the first, remove return hello world and happy. Of course, because it match a single occurrence from the right, a white space followed by anything, which is more or less this part, and remove it and return all the rest. And with the double percent, it matches the longest. So this is for the shortest match, and this means the longest match. And once the longest match detected, which would be this, a space followed by anything, then you remove it and return just hello, which is the result that we have on the last line here. And this is also practical for trimming operations. Let's say we have a file name with some extensions, let's say data.png, and we want to trim the .png part, and we want to remove the extension from it. Or maybe a little bit more useful one would be, let's say we have some HTTPS pound, let's say example.com/path, and followed by a hyperlink introduction. And let's call this URL properly. And we want just to remove the hyperlink and just get the path, let's say. Then we will just do it this way. So our variable name is URL. We want to remove from the right or from the end of the string pound followed by anything. So pound followed by anything. And this is our URL that we are interested in. So this, yeah, just remove our URL without the hyperlink at the end. And if we want to get everything till the base path, then we just need to remove it. In this case, instead of using the longest match would be the singles match. Otherwise, it will match up to this slash here. So we want the shortest match until we reach the base path here. So it's a single %sign, a slash, followed by any character. And this, we get the base URL returned. And if we just want the domain name, we can combine this. So we can use this and set the URL to this, and then the URL. So this removes these parts. And if we just want the domain name, then we need to trim the HTTP column / from the beginning. And to trim from the beginning, we just need a single pound for the shortest match, let's say, and anything followed by a column / would be fine. And then we'll just print our URL without, just this way. And then in the end, we just get the domain name or host name. So yeah, it's possible to combine all these different expansions to achieve whatever kind of formatting or trimming that is needed. It's also possible to do find and replace kind of operations. Use the slash operator. So we need to specify the parameter. And after the first slash, we define the pattern that we want to match, and another slash to define the new the string that we want to use to replace our pattern. So a single slash would replace only the first occurrence, and if we use a double slash, it will return all occurrences in the string. And we can combine this with the pound. So if we use slash pound, it will replace the first occurrence of the pattern from the beginning of the string. And with slash %sign, it will replace the first occurrence of the pattern from the end of the string with what we specified. So we can check this around, or let's say, instead of keeping all this, let's just comment this all parts out and keep only the part we are interested in commented. A cool world and happy world is a world in code. Does not mean anything, but practical we have words multiple times, so will be practical for string replacement. So if we want to only replace the first occurrence of world with developer, for instance, then we just need to do echo. Our variable is greeting $, and we want to replace the first occurrence of the pattern, which is world, with developer. And then this will print a cool developer, and happy world is a world in code. A cool developer and happy world is a world in code. So with a single slash, then it only matches the first occurrence of the world. But if we use a double slash, and the double slash should just be used immediately after the variable name, so it will replace all occurrences of world with developer in the string or in the variable greeting. And this is a cool developer, and happy developer is a developer in code. So that's it. So the pattern match with the slash pound, if we match like anything until world, then this will match these parts of the string, and this whole part will be replaced with developer. And if we match here world followed by anything, then it will match this whole part, world in code, and this whole part will be replaced with developer. And that's the difference about the match from the beginning and match from the end. So the pattern has to match the whole beginning of the string, otherwise the string will be left unchanged. And from the end, it also has to match the whole end of the string, otherwise the string will also be left unchanged. Yeah. And last but not least, there are the nice case conversion operators. For the case conversion, there is the caret operator, and a single caret only change the pattern in uppercase, and the pattern ideally should only match a single character, and the character that it matches will be converted into uppercase. Yeah, but only that character, and from the beginning, or the first character. But if it does not match the first character, then the character will be left unchanged. But to convert the entire string into uppercase, then we use the double caret and followed by the pattern. So every time the pattern is encountered in the string, it will be converted into uppercase. But if the pattern is not specified, then the whole string will be converted into uppercase. And the same principle applies with the comma operand, and the comma operand converts into lowercase. Yeah, so with a single comma, only the first character that match the first character, if it matches the pattern, will be converted into lowercase. And with the double comma, then all characters that match with the pattern will be converted into lowercase. And if pattern is not specified, the entire string will be converted into lowercase. And notice that with the caret and the comma operand, pattern should match a single character. So you can try this with our string, the greeting. So greeting, if we use a single caret, it will just convert the first character into uppercase, but the third character here is already in uppercase, so it will make no difference at all. And if we use double caret without any pattern, then the entire string will be converted into uppercase like this. But if we want, for instance, only the letter W to be converted into uppercase in the entire string, then we can specify So if we want only the character W to be converted into the uppercase, all occurrences of W in the string to be converted into uppercase, then we match W followed by anything, then convert W into uppercase. And then in that case, in executed, we have world here converted into uppercase. So if we have, let's say we declare a variable title, which is Mr. or Mrs. and want to convert this, then we can just do title, please. Without argument means the first character, and then we will just have Mrs. the first character automatically converted into uppercase. And to have everything into lowercase, then instead of caret, we just use, let's say we have Mr. We can use the double comma to convert all characters into lowercase, or a single to convert only the first character into lowercase. So only a single comma will convert the first character into lowercase, so M is in lowercase and everything else is left untouched. But with the double comma, then the entire string is converted into lowercase. And when we apply this, let's say this is world this way and used with greeting and with double comma, and the last time we print greeting, it should be then in all lowercase, although here I changed the case of world, for instance, in all cap. So this is definitely much better way to do string conversion compared to using the tr commands, for instance. So let's say we have a variable, I would just call it value, hello world, and we want to print value this way. Then we have hello world. We want it to be all cap. We just need the double caret, and then it's automatically in all cap. Now this is better than having echo and pipe it into tr and use the class from lower to upper, and then this will also convert to all cap, but it involves a little bit more, creating a pipe, running the external command tr to convert everything from lowercase to uppercase. This is not much efficient. Yeah, using the caret is straightforward, all happen in the single bash instance and way more efficient.